Here we have a transistor control circuit. It's measuring the temperature, and in the cold it's switched on here. If that's a variable resistor, you can change the point at which the transistor switches on. Okay, right, how does it work? The input to the system is a voltage divider. These two resistors make up a voltage divider. As the temperature drops, the resistance of this thermistor increases. Okay. With that increase in resistance, the voltage out of the potential divider, V out, will increase. So when that resistance increases, that increases. Okay. The transistor will switch on when that voltage there is VBE, when VBE equals 0.7. The transistor will switch on. A small current flows into the base of the transistor. Now, that small current is probably going to be about 100 times bigger current travels down through here. That bigger current will switch on the relay pulling the switch and switch on here. The transistor here is to protect the base of the transistor from large currents coming this way. The diode also protects the transistor, but protects it from back EMF from the relay. When we're doing calculations involving these circuits, now that V out, if I call that V1 there, V out equals VBE plus V1. The current flowing down here, I1, will be split. I1 equals I2 plus I3. Okay, Kirchhoff's current law. That's just Kirchhoff's voltage law. Now, sometimes they'll give you a relay and they'll tell you it's 6 watts at 12 volts. From that figure, you calculate the resistance of the relay. In this circuit here, it probably isn't going to be 12 volts across there. The question might tell you what this voltage between that point and 0 is. Okay? So if that was 1 volt, that would mean the voltage across your relay was 11 volts. So from this, use P equals V squared over R. So R equals P over V squared. Okay. That'll get you the resistance of the relay. Okay. From the resistance of the relay and this voltage, you'll be able to find the current flowing down here, which is IC, the collector current. IE, the emitter current, you can assume is the same as IE, although the IB does come in. This one's so small compared to these currents, it doesn't really make much difference. Once you have IC, use the formula HFE equals IC over IB. So IB will equal IC over HFE. So you can calculate the current flowing there. Once you have the current there, this V equals the current times the R, so you get that voltage. So we now know V out can work out. We know that current, you can work out that current. These questions, it's just a case of looking at where you know either the voltage and the resistance, when you know two out of the 3, and then calculating the third one, and then that will feed into something else. Use Kirchhoff's laws, so the currents are flowing about, if you work out them. And if you remember, if you sort of start here at 0 volts, whether you walk up this way to get to that point, so it'll be 0.7 plus V1 to get to there. It's exactly the same voltage as if you walked up through there. Okay, so that's at the same pressure, whether you come up through this way or through that way.